Every second, your heart beats automatically, keeping you alive without a single conscious thought. But beneath that steady rhythm lies a fascinating partnership between physics and biology. Your heart isn't just a muscle, it's also an electrical system. Each beat is triggered by tiny electrical signals that travel through the heart in a perfectly timed sequence, causing the muscle fibers to contract and pump blood. This process is so precise that even the smallest disruption can change how your heart feels and works. Understanding this hidden electrical world reveals just how much physics is at play in every pulse you feel. Let's explore how your heart creates and controls these life-sustaining signals. Like most muscles, the heart doesn't wait for the brain to tell it when to beat. Instead, it has its own built-in electrical generator, the sinoatrial SA node. This small cluster of specialized cells in the right atrium acts as a biological pacemaker, firing off tiny electrical impulses about 60-100 times per minute. These impulses spread through the heart in a coordinated pattern, first causing the atria to contract and push blood into the ventricles. Signal then pauses briefly at the atrioventricular, AV node, before traveling down the bundle of His and into the Purkinje fibers, triggering the ventricles to contract and send blood throughout the body. This beautifully timed sequence repeats itself every second, keeping your heart's rhythm steady and reliable. At its core, the heartbeat is powered by basic electrical principles, the same ones that run your phone or computer. When the SA node fires, it changes the voltage across heart cell membranes by moving ions like sodium, potassium, and calcium. Normally, the inside of a heart cell is negatively charged compared to the outside. When an impulse starts, ion channels open, letting positive ions rush in. This sudden change, called depolarization, triggers the muscle to contract. Afterward, the ions move back out, resetting the balance in a process called repolarization. Each heartbeat is a wave of depolarization traveling across the heart, like a ripple in water, perfectly timed to keep blood moving. Doctors can actually see your heart's electrical activity using a machine called an electrocardiogram, or ECG. The ECG doesn't measure the heart's contractions directly. It records the voltage changes as electrical waves move across the heart. Each spike and dip on the ECG graph represents a different part of the heartbeat. The P wave shows atrial contraction, the QRS complex marks the main pumping action, and the T wave signals recovery. By studying these patterns, doctors can spot irregularities like arrhythmias or blockages. Thanks to physics, we can literally watch your heart's electricity in action, helping diagnose and treat heart problems. Sometimes, the heart's electrical system doesn't work perfectly. If the SA node fires too quickly or slowly, or if signals take abnormal paths, the result can be arrhythmias, irregular heartbeats. Examples include bradycardia too slow, tachycardia too fast, atrial fibrillation chaotic signals, and heart block delayed or blocked signals. Modern medicine can often fix these issues using pacemakers or medications that help regulate the heart's electrical activity. Pacemakers are small devices implanted in the chest that send electrical impulses to keep the heart beating at a healthy rhythm, stepping in when the body's natural wiring needs help. Our heart is an energy marvel, beating about 100,000 times a day while using surprisingly little energy. Each electrical impulse triggers a wave of contraction, pumping blood efficiently through your body. The heart converts the electrical potential of ion movement into mechanical energy, powering every cell. This is physics at its most elegant, electricity transformed into motion, perfectly tuned to sustain life. A heartbeat is a beautiful example of physics and biology working together, balancing charge, motion, and energy with breathtaking precision. Every pulse you feel is the sound of physics keeping you alive.